Part A then wants us to find the points of intersection of these two curves. So we need to solve 2 sine x plus 2 equals minus 2 sine x plus 4. So collecting the sine x terms on one side, we get 4 of them. So 4 sine x equals 2. So sine x is equal to a half. So inverse sine a half on your calculator, x comes out to be pi by 6. And then pi minus pi by 6 gives me the next solution, which is 5 pi by 6. And then to get the third solution over here, I need to add 2 pi onto this first one. So 2 pi added onto this one gives me 13 pi by 6. So there's my x coordinates. Now to find the y value, what I'm going to do is substitute x equals pi by 6 into one of these equations. So let's go for the first one. So 2 sine pi by 6 plus 2. Well, sine pi by 6 is a half. Twice a half is 1. So 1 plus 2 gives me a y value of 3. Now I don't need to repeat this for the others because the sine of 5 pi by 6 and the sine of 13 pi by 6 are both a half. So 3 is the y value for each of these. So my coordinates are going to be pi by 6, 3, 5 pi by 6, 3, and finally 13 pi by 6, 3. So part B asks us to find the shaded area. So again, I need to do this in 2 parts. So I'm going to find this area first. This is my small area, and then I'm going to find the larger area. So for this small area, the curve at the top is 2 sine x plus 2, and the curve at the bottom is minus 2 sine x plus 2. So I'm going to integrate 2 sine x plus 2, take away minus 2 sine x plus 4 between the limits of pi by 6 and 5 pi by 6. Now if I simplify this, there's my pi by 6 and my 5 pi by 6, what I end up with is 4 lots of sine x, and I've got a plus 2 there and a minus 4 coming here, so a minus 2. So when I integrate sine, I get minus cos, so minus 4 cos x minus 2x, and again my limits pi by 6 and 5, oops, pi 5 pi by 6. And if I substitute these in, what I'm going to end up with is minus 4 cos pi by 6, so that's minus 4 cos pi by 6, 5 pi by 6 I should say, minus 2 lots of 5 pi by 6, and then take away minus 4 cos pi by 6, take away 2 lots of pi by 6. So if we work this out, this gives me 2 root 3. This one here is a minus 5 pi by 3. Minus and minus is a plus, and again this is a 2 root 3, and this again a minus and a minus makes this a plus pi by 3 on the end. So altogether what I end up with is 4 root 3 minus 4 pi by 3. And then I do exactly the same thing for the large area. Oops, it's not part C top. So for the large area, what I'm going to do is integrate between 5 pi by 6 and 13 pi by 6. Now this time, when you come back to my diagram here, the curve on the top is the minus 2 sine x plus 4, and the curve on the bottom is the 2 sine x plus 2. So I've got 2 options here. I can do this one, take away this one and integrate, or I can use what I did before and if I integrate this one here, I know my answer is going to come out to be negative, and then all I've got to do is change the sign round at the end. So that's what I'm going to do. So I'm going to take the same curve here. So if I want to integrate 4 sine x minus 2, I know this gives me minus 4 cos x minus 2x. So again, what I'm going to do is put my limits in here. So put my limits in, and I get minus 4 cos 13 pi over 6 minus 2 lots of 13 pi over 6, and then take away what I get when I put 5 pi by 6 in. Now I've already done this up here, yeah, so 5 pi by 6 gives me a 2 root 3 and a minus 5 pi by 3. Actually gives me a minus 2 root 3, I should say. Okay, so if I then sort this out, what I end up with eventually is minus 4 root 3 minus 8 pi over 3. Therefore my area is going to be minus this. Yeah, I need to change the sign. So my area is 4 root 3 minus 8 pi by 3. If you want to do this the other way around, by doing this one, take away this one, you will end up with exactly the same answer, but you won't have to worry about changing the sign because it'll come out to be positive. Okay. And then finally part C asks us for the ratio of the small area to the large area. Well, my small area is 4/3 minus 4 root 3 minus 4 pi over 3. So what I'm going to do with this is I'm going to take 4/3 out as a common factor, and I'm left with 3 root 3 minus pi. Okay, and then for the large area I'm going to do the same thing. I'm going to take 4/3 out as a common factor, and what I'm left with again is going to be 3 root 3, oh it's a plus there, I beg your pardon, that should be the plus, plus 2 pi. Yeah, therefore the ratio of the small to the large is going to be 4/3 3 root 3 minus pi to 4/3 3 root 3 plus 2 pi. Well, I can cancel the 4/3 out because a ratio is basically just a fraction, so my ratio is going to be 3 root 3 minus pi to 3 root 3 plus 2 pi.